Okay, so this one looks really scary. Why does it look scary? Because there's fractions, but of course when you look at that, what do you notice about those bases? They're the same. So isn't this the same as having an x there? Then it's really easy. It's x to the negative 8 times x to the 6th. What do you do with those exponents? You add them to get x to the negative 2. What does a negative exponent do to the base? Flips it over, right? So right now the base is negative 3 over 2 to the negative 2. What does that negative do to the fraction? Flips it over. So it's now negative 2/3 to the positive 2. Now somebody should say, when you flip it over, why don't you lose the negative? Why don't I lose the negative? Pardon me? This negative has nothing to do with the exponent. Right? This negative says this is the base. It is negative 3/2. And whatever we do with the exponents, this thing is negative. So that doesn't change. Now I have negative 2/3 squared, which is, of course, 4/9. Because the negative is inside the bracket, so it's part of the squaring. Everybody good? All right. This is 1.4 to the 7th. I lie, to the 9th. Because 3 plus 4 minus 2 is 9. Now, I'm perfectly happy with this, but if you really care, you can put that into your calculator and give me a value. Everybody understand? I don't really care. You could also say that's 14 over 10, which would be 14 to the 9th divided by 10 to the 9th. You can do all kinds of stuff with that. But since this is an exponent unit, that's what's important to me. Everybody good? Okay. This one is tricky because of fractions, but again, rules don't change. That is 7 to the 2/3 over 7 to the 2. That is subtraction. So that is 7 to the 2/3 minus 6/3, which is 7 to the negative 4/3, which means negative exponent does what to my base? Flips it over. 1/7 to the 4/3. You can leave it like that, or you could write 1 over the cubed root of 7 to the 4th power. I would accept both of those things if I were marking this on a test. Okay? Now, in case you have teachers that are a little more picky than I am, they might say, I want exponential form. That's that guy. Or they may say they want radical form. And that's that guy. Everybody cool? I don't care. If I do care, I will tell you which one I want. Okay? X to the 5th, y to the negative 2, so that's x to the 5th over y squared. And this one is 2a squared b to the 5th. Any problems on that page? Once, twice, thrice? Everyone's good? Okay. Should I go on with this? Or do people want some time now to look over 109 and make sure they did it right? It's Friday. This first block is for you guys. It's to make sure you're ready to go. Because you're about to do an assignment on this 4 marks. And you have a test on Monday. Do I carry on with this or do I shut up? Isha. Pardon me? Number 10. Just number 10? Everybody feels they're okay with the rest? Okay. Why don't I just throw out the answers to this? It's no big deal. And then I'll go over the ones that you need gone over. Deal? All right, so this one is 1.5 to the 15th over 1.5 to the 5th, which is 1.5 to the 10th. This one, there's a lot of ways you can do this. Number 8, okay? There's a lot of ways you can do this. I'm going to show you one way. Maybe you didn't do it this way. If you didn't do it this way and you got the same answer as me, that's fine. If you didn't do it the way I'm about to do it and you have a different answer, then we need to talk. Does everybody understand that? Okay. So in this one, you could look at it two ways. One, you could look at it, say that's an exponent, so that just goes to everything inside, doesn't it? So it's 8 to the 1/3. 3 times 1/3 is 1, and 6 times 1/3 is 2. 1/3, 8 to the 1/3, is the same as the cube root of 8 to the first power, yes? Cube root of 8 is 2ab squared. That's done. You could also have done this. Because this has brackets, this whole thing is the base, isn't it? So that means if that's the base and I have a fraction for an exponent, cube root, the base becomes the radicand, and all of that is to the first power. Because it's to the first power, I don't need to care about it, do I? So it's just the cube root of that. Cube root of 8 is 2. Cubed root of a to the 3. 3 divided by 3 is 1 with no remainder, so out comes 1. 6 divided by 3 is 2 with no remainder, so out comes that, and I left nothing underneath, and I get the same answer. Do I care which method you use? Who makes this decision? You do, depending on what you're comfortable with. Are you more comfortable with all the exponent laws, or are you more comfortable using radicals? The only person that knows that is you. Understand? All right, now, Erilyn, you specifically asked about number 9. So, number 9 looks weird and scary because of the fractions, right? But everything's got the same base, yeah? So I just follow all the regular rules. First, I do the numbers. What's 4 divided by 2? 2. A and A, are they the same base? So I subtract the exponents, right? What's negative 2 minus 2? No. No. Negative 4. Okay, I can't stress this enough, ladies and gentlemen. If you're bad at adding and subtracting negative numbers, I already marked you as absent. Did you sign into the office? Don't worry about it. I'll fix it. If you are bad at adding and subtracting negative numbers, and by bad, how do you know you're bad? Well, if every time I ask what's negative 2 minus 2, you give me the wrong answer, that means you're not very good at that. Does it mean you can't do it? No, of course not. It just means that your first reaction isn't right. And it's not just you. It's everyone. Trust me. We had a pep rally here this year where kids got to put a pie into the teacher's face if they couldn't answer a question right. So I got up there and I asked the kid, what is negative 7 minus negative 3? What is it? It is negative 4. See? And the kid stopped for a second. He went negative, and then he stopped. Negative 4. And we were in front of the whole school, right? And I had a microphone. I said, hey, school, is he right? In front of the whole school. And like 5 out of 1,000 people, yeah. Everyone else was like, oh. He was right, so he got to put a pie into my face. The point of it is, it's not just you, right? If you make the wrong answer every time I ask, then start using your calculator to do this until you get it into your heads. Understand? And then, what do I do at the B here, Erlen? They're the same base, so what do I do with the exponents? Pardon? I subtract them. So 2/3 minus 1/3. What's the answer? What's the answer? 1/3. So I got B to the 1/3. Now what there is totally not allowed? The negative 4, right? So that has to go to the denominator. Is this allowed? Is this allowed? Is this allowed? He waited patiently for one of his 28 students to say yes or no when he is highlighting whether it is allowed or not, and still not getting an answer from 28 students who are about to write a test on this subject. Thank you. It is allowed. Could you write it another way? Yes, you could write 2 cube root b over a to the 4th. Both of them are allowed. Now, 10. 10 looks a lot like 8, doesn't it? Right? Which means there's probably more than one way to do this question, yes? Actually, I can think of 3 ways to do this question off the top of my head. The way I'm about to show you is what I feel is the easiest way to do this. You might disagree. I look at the question and I see, hey, wait a minute, 25 and 100 work together pretty well. A and A work together pretty well. I'm going to tidy up inside here first. So 100 divided by 25 is 4, yes? What do I do with A to the 1 and A to the 5th? Subtract. What's 1 minus 5? Negative 4. Now, I'm not going to move him yet because it's not the very end. There's still stuff happening. That guy might change. And there's no B up top, is there? So this B on the bottom has a negative exponent, doesn't it? So I'm going to move that up to the top. Is everybody cool with this equaling this? Does everybody understand everything that happened? Yeah? Okay. So all that's in brackets, and then I got 1/2 out here. This is the way I do these. I bring the 1/2 to every exponent. And since it's going over a bracket, it multiplies those exponents. What's the exponent really with 4? It's 1, yes? So this becomes 4 to the 1/2. A, what's 4 times 1/2? 2. A to the negative 2. And B, what's 1/2 times 1/2? 1/4. I'm almost there. 4 to the 1/2 is the same as the square root of 4, yes? Right? Which is 2. A to the negative 2, is that allowed? No. Right? That becomes 1 over A to the positive 2. So now I've got something in a denominator. A to the 2. B to the 1/4, is that allowed? Yes. So I could write that. Or I could write 2. How would I turn this into a radical? 4th root of what? B to what power? First. Do we write it? No. Over A squared. And again, I do not care which one you do. Everybody good? Okay. And lastly, these 2 questions. How many of you take this and sub it in here right away? Be honest. A few of you do, right? What do I say you should be doing all the time? Every chance you get, what do I say you should do? Simplify. Does this simplify? Yeah, it does. Because I have x and x. What do I do with those exponents when I'm multiplying? So now I have x to the 3/2 plus 1/2. What's 3/2 plus 1/2? X to the 4th. What do I do with the 2 and the negative 1? For y. Add them. What's 2 plus negative 1? That's y to the 1. Isn't that easier to sub into than this mess?
Isn't x, it would be x to the
Oh, yeah, x to the 2. Thank you. Because it was 4 halves, yeah. Isn't that easier to sub into than this mess? So now, x is negative 2. So I have negative 2 squared, and y is 3 to the 1. What is negative 2 squared? 4. What is 3 to the 1? 3. So the answer is 12. Simplify first. So knowing what I just told you, what should I do now? Simplify first. Now this one's really tricky. Right? Because I got to simplify that first, don't I? So that gives me x to the 4th times negative x to what power? The 12th. All that cubed. Everyone agree? Now, negative x to the 12th. Negative is going to go an even number of times. What will that do to that negative base? It will make it positive, correct? So this is x to the 4th times positive x to the 12th, all cubed. What do I do with these two numbers? Add them to get what? X to the 16, all to the 3. What do I do with that number? Multiply it to get what? X to the 48th. What is x? Negative 2 to the 48th. That number is immeasurably large. That is 2 times 2, 48 times. Most of your calculators won't even show the number the way it's written. 2 y to the x, 48. Because negative 2 to the 48th is the same as 2 to the 48th, right? It's that. And the decimal place is going to move 14 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 5 more zeros. Big number. Right? Is everybody cool with 109, 110? Oh, wait, I'm not done, am I? Am I? Oh, no, there's those two. But I did those yesterday, right? Didn't we? Didn't we do the last 3 yesterday? Oh, I did one of them. Right. Start with the formula, fill in what you know, and then do algebra. Do people need me to do the algebra? I don't mind. How do I get rid of divide by 3? Multiply both sides by 3. Cancel, cancel. 3. 3 times 425 is 1,275 equals 4 pi r cubed. How do I get rid of 4 times pi? Divide by 4 pi. What do I do to this side? Divide by 4 pi. Now this is trouble because a great many of you do not know how to do this on your calculator. Everybody try to do this on their calculator right now. Tell me what you get. Some of your calculators will do it right. Some of your calculators will do it wrong. Depending on how you punch it in. If you don't know how to punch it in. Now, have I punched in that? Does everyone agree? 1,275 divided by 4 pi. Is everyone agreed? And I get 1,001. Does that make sense? Stop for a moment. Think. Does that answer make sense? Here's what I mean by that. 1,275 divided by What's pi close to? So isn't this 12? 1,275 divided by 12. Isn't this pretty close to 1,200 divided by 12? So shouldn't my answer be pretty close to 100? What is my answer? How many of you would write 1,000 here? Put your hands up. If you punch into your calculator and your calculator said 1,000, what would you write here? You would write 1,000, wouldn't you? But it can't possibly be 1,000, is it? So what has my calculator done that allows it to be 1,000?
It's dividing by 4 and then multiplying it by pi.
Exactly. It's doing exactly what I told it to do. It's following BEDMAS, isn't it? And in BEDMAS, division and multiplication are equal, right? So my calculator is taking 1,275 and dividing it by 4, which is about 300, right? And then multiplying 300 by pi, which is about 3, right? 300 times 3 is 900. That's what my calculator is doing. So how do I make my calculator give me the right answer? Brackets. 1,275 divided by bracket 4 pi. Close brackets equals. Oh, I did times. Thank you, Josh. Or Zach. 1,275 divided by bracket 4 pi. Does that make more sense? Excellent. So now it's 101.46, right? How do I get rid of a cube? Cube root. So I go back to my calculator. For me, I have to go math, cube root, answer, because it's my last answer, enter. And I get 4.7 equals R. Now, what am I testing you on here? I'm testing you on algebra, really, aren't I? And how to get rid of a cube. That's radicals. Right? Okay. And the last one, a cone with equal height and radius has a volume of that. So the volume of a cone is pi r squared h divided by 3. Right? H and r are equal. Right? So what does that mean I can change this h to? An r. Correct? Which means now I have r squared times r. So what do I have? Pi r cubed over 3. Right? That equals my volume. Now, can I fill this in? Sure I can. Pi r cubed over 3 equals what? 18. And then it's the exact same as up here, yes? Except there's no 4. So I multiply by 3. Pi r cubed equals 72. Then I divide by pi. R cubed equals 72 divided by pi. And what's the last thing I do? Cube root. Now, are you allowed to leave this as an answer? Are you? Sure you are. Why wouldn't you be? Have you done the work? If you leave it like that, do I give you full marks? Do you think? Just wondering. Absolutely I would. Now, if you remember what we talked about yesterday, you could tidy this up, couldn't you? Because this is the cube root of 72 over the cube root of pi, yes? Cube root of 72, you can fix that up. That's 2 cube root 9. Because it's 8 times 9, right? Yeah? Is it? 18. Oh, it is 54. 18 times 4 is 72. So it's a cube root of 54. Still, no problem. That's 27 times 2, right? So that's 3 cube root 2 over the cube root of pi. Now, in grade 10, if you leave it there, I'm perfectly happy. But I told you yesterday, I showed you where you were to go. Would we be allowed to leave that down there? A radical on the bottom. No, we wouldn't. And we'd fix that up. But you guys don't have to, right? If you leave it there, except that would be, of course, 54. I'd be happy. Or you could do the decimal. 54 divided by pi and cube rooted on your calculator. Both of which would be acceptable. Is everybody good? All right. Now, I got 833. You've got the answers to 111 and 112. So make sure you're good at them because, like I say, 20 years of teaching math, everybody thinks that exponents are easy, but they're not. So make sure you're good at it. Okay? The review starts on page 111 and goes to page 117. I lie. The review starts on 113, 14, because you got 2 pages of answers there, right? That is due for marking at 10:55. Because you're going to do your cumulative in the second block after the first break. Yes? The cumulative is not very long on purpose. So you have some time to finish this up. Okay? It's like 7 multiple choice questions, 4 on the first unit, 3 on the other unit, and 3 open-ended questions on both. It's not very long. So you'll have extra time to make sure this gets done. Everybody cool? Yeah? Okay, I'm going to shut up. I'm going to give Loveline her quiz that she missed yesterday.